will teach you how to find the maximum or minimum point of a function, meaning the vertex point of a parabola, from the factored form of a given relation. Now, in this relation, we have y equals 2 times x minus 1 times x minus 5. If I would look at the graph, and this would be my x-axis and this is my y-axis, we know that the parabola, if it has roots, it will intercept the x-axis. Let's first identify the variables. First of all, the a in the function is 2, which means that my parabola will be stretched. Now, since the a is a positive number, I know my parabola will open up, which means it will have a minimum point. Now, what is that minimum point? In order to graph a function on the graph, we need minimum 3 points. The vertex point and 2 other points on either side of that vertex point. Now, the vertex, we know, is given by P and Q. The function that's provided over here is not in vertex form, it is in factored form. And I want you to remember what is the factored form of a function. We said it was y equals a x minus r x minus s. That is the factored form of a function. Now, in my case, a is 2. Let's look at r. Can you see the connection between r and s and my provided function? And hopefully you can see that r is 1 and s is positive 5. So let's write them down. So r equals to 1 and s equals 5. So if those two are the x-intercepts of that function, let's plot them on the graph. So this is 1, 2, 3, 4, and 5. And the two x-intercepts are at 1 and 5. Now, the x-intercepts are at equal distance from that axis of symmetry. So if I look at right in the middle, somewhere here, I have that axis of symmetry that would split my parabola in 2 equal sides. And somewhere along this axis of symmetry, I will have my vertex point. Now we have to find out where. Well, if the two x-intercepts are at equal distance from the axis of symmetry, we can find it by averaging the two x values to find the midpoint between the two. So, step number 1, we're going to average the two x-intercepts to find the axis of symmetry. Now, in the vertex point, which of the two variables gave us the axis of symmetry? And I hope you do remember that P was the one that was giving us the axis of symmetry. So let's substitute now. R is 1 plus S is 5 over 2 equals 1 plus 5 is 6 divided by 2 is 3. So the axis of symmetry is at P equals 3. So we already found one value in that vertex point. Now let's think about the Q value. If I know the x coordinate of the vertex, how would I be able to find the y coordinate of the vertex? Y being represented by Q. Well, I can substitute that 3 back into the factored form. So step 2, substitute P in y equals a x minus r x minus s. So substitute P for x. So let's look at what my equation is going to look like. I have y equals 2, 3 minus 1 times 3 minus 5 equals 2 times 2 times -2 equals -8. So that q, or the y value of the vertex, is -8. And I can now conclude that the vertex is given by the coordinates v. The vertex is 3 and -8. And if, let's say, this would be -8, I know it's not a scale, but we can go over the writing. My vertex would be right here, and my parabola would go down and then go back up through 5. And that's how we find the vertex, starting from the factored form of a function.